Today we are going to learn about the differentiation of Trigo functions. Here are the rules for the differentiation of Trigo functions. Differentiate sine, you get cos of the function, and when you have to differentiate the function and place in front. Similarly, differentiate cos, you get minus sine of the function. You differentiate it and place in front. Differentiate tangent, you get secant square. Again, you copy the function, you differentiate this function and place in front. In all the three rules, you notice that after copying the function, you will need to differentiate this function and place the differential in front. Now, let's learn the differentiation of Trigo functions here. This will help you remember this rule clearly. The differentiation of Trigo here goes like this. Differentiate sine cos. Differentiate cos minus sine. Differentiate tangent secant square. Let's cheer it one more time. Differentiate sine cos. Differentiate cos minus sine. Differentiate tangent secant square. Now let's do the cheer one last time. Differentiate sine cos. Differentiate cos minus sine. Differentiate tangent secant square. With this, you are ready to do some examples on the differentiation of Trigo terms. Suppose you are asked to differentiate sine 3x. So you just cheer. Differentiate sine cos. Copy 3x. Differentiate 3x, in which you get 3, and you place it in front. Next, if you're asked to differentiate cosine half x plus pi, you just cheer. Differentiate cos minus sine. Copy the whole function, after which you have to differentiate this whole function. Differentiate half x, you get half, plus differentiate pi, you get 0. So the differential of half x plus pi is half, in which you place this half in front. So the overall answer is minus half sine half x plus pi. Next, what if you are asked to differentiate tangent 2 pi minus x over 3? We notice that there's a constant 1/3 for this expression. So we take out the constant 1/3 and we differentiate the tangent term, which is tangent 2 pi minus x. So we do the cheer, differentiate tangent secant square. Copy the whole function 2 pi minus x. And then we differentiate this term, in which we get minus 1. We place it in front. So 1/3 times minus 1 will give you minus 1/3. Secant square 2 pi minus x. So we have finished the differentiation of simple Trigo terms. Now let's move on to the differentiation of Trigo functions raised to power n. Here are the rules. So let's analyze the differentiation of sine power n fx. We first rewrite the term into sine fx, whole bracket, raised to power n. So when we differentiate this sine fx function raised to power n, we will do the chain rule here. Power comes down, then this power minus 1, then we differentiate inside the bracket, in which we get cosine fx, differentiate fx, in which you get f prime x, and you place it in front. For the rest of the Trigo functions, you will use the same rule. So let's go ahead and take a look at some examples. For example, you're asked to differentiate sine square 3x. You first rewrite it into the differentiation of, open bracket, sine 3x close bracket square. With this bracketed term, you can then do your chain rule here. Power comes down, power minus 1. Differentiate inside the bracket. Differentiate sine 3x, you're going to get cos 3x, and then when you differentiate 3x, remember to put the 3 in front. So 2 times 3 will give you 6, followed by sine 3x and cos 3x. But we bear in mind that if 6 is separated into 3 times 2, then 2 sine 3x cos 3x using the double angle formula is actually sine 6x. So the answer is 3 sine 6x. Let's move on to the next example. Suppose you are asked to differentiate tangent power 4 2x plus pi. So what we do is, we rewrite the term into the differentiation of tangent 2x plus pi whole thing raised to power 4. With this bracketed term, we can do our chain rule here. Power comes down, power minus 1, differentiate inside. So differentiate inside the bracket, tangent 2x plus pi, you get secant square 2x plus pi, then remember to differentiate inside the bracket again, in which you get a 2. So collating the constant terms, 4 times 2 will give you 8, tangent cube 2x plus pi, secant square 2x plus pi. What if the Trigo term involves a square root? So in this example, we have the differentiation of the square root of, open bracket, 4 minus 3 cos 2x, close bracket. So again, we rewrite the differentiation into the open bracket, 4 minus 3 cos 2x, close bracket, power half. The power half is due to the square root. With this bracketed term raised to power n, again we have the chain rule here. Power comes down, power minus 1, and we differentiate inside the bracket. So when we differentiate 4, we get 0. When we differentiate minus 3 cos 2x, we'll get 6 sine 2x. So at the end of it, you're going to get cancel the 2 with a 6, and you'll get 3 sine 2x over the square root of 4 minus 3 cos 2x. Now let's move on to some examples involving the product rule of Trigo functions. If we are asked to differentiate sine x times tangent x, we have 2 terms that multiply each other. So what we do is we can use the product rule. We call sine x the first term, and we call tangent x the second term. So the product rule goes like that: copy first, differentiate second term, plus copy second term, differentiate first term. So sine x, after differentiation of tangent x, you get secant square x, plus tangent x, after differentiating sine x, you get cos x. Okay, the last example will involve quotient rule. If you're asked to differentiate cos x over x, so what we do is, since it's a fraction, we'll use the quotient rule. The bottom, the denominator square, then we copy denominator, differentiate numerator, in which we get minus sine x, then we minus, copy numerator, differentiate the denominator, in which you get 1. So simplifying the terms, you get minus x sine x minus cos x over x squared. So with this, we've finished learning the differentiation of Trigo functions. I hope you have understood this short lesson.